Now, to get a more precise answer for our system of equations, solutions, we would use either substitution or elimination. And in the case that the two following cases, we're using substitution because it's an obvious choice. They work quite well together. In this case, y equals negative 5x plus 16, and we have y equals 2x minus 12. So the obvious substitution would be to take this negative 5x plus 16 and replace this y with it, because since they're both equal to y. So basically you get minus 5x plus 16 equals 2x minus 12. Again, we're simply going, okay, instead of y here, we're putting minus 5x plus 16 in to replace it, or substitute it. And now we solve for x, and in that case we're going to subtract 16 on both sides, and we get negative 5x equals minus 28, and we subtract 2x on both sides. Oh, we've got our plus 2x here, so we're going to subtract that 2x on both sides, get minus 7x. All right, minus 7x equals negative 28, and then we divide by negative 7. We're going to get x equal to 4. X equals 4 gets substituted back into either equation. When we do that, we're going to get our y value of the coordinate point that is our solution. In other words, where the lines cross. So x equals 4, we're going to put that back in. I'm going to lower this down. Y equals 2x minus 12. I'm going to put that x equals 4 right into there. And we're going to get y equals 2 onto 4 plus 12. And that means y equals 8 plus 12. And y equals 20. And again, the significance of that is that we've found our x and y value for 20 that is going to be the solution for this system of equations. In other words, if we had a graph, if we were looking at a graph, we would find the point for the 4 value for x and then 20 for y, and on that point would be the place where these two lines would cross. Very precise, this one, and it's substitution. Now another example of substitution, perhaps a little bit more difficult with the mathematical or the manipulation part of it. You are taking, again, we're substituting, but this time we're going to substitute the y equals negative 5x plus 16 is going to be substituted into an equation of standard form. So this right here, this minus 5x plus 16, is going to go into here where that y is. And what do we get? Well, we're going to rewrite it. 2x plus 5. Now, instead of a y, we're going to make brackets equals 11. And that minus 5x plus 16 is literally going into there to substitute for, which I'll do in a different color. So minus 5x plus 16 goes in. It's substituted in, as you can see. So, again, 2x plus 5 onto minus 5x plus 16 equals 11. With the minus 5x plus 16 being substituted in. Now, once you've done that, you have to distribute the positive 5 onto negative 5x and positive 5 onto 16. And we just proceed as we normally would, solving this for now for x. 2x minus 25x plus 80 equals 11. We've got negative 23x, and we're going to subtract 80 on both sides. And negative 23x is equal to, let's see here, minus 80, so we're going to have minus 69. And then when we divide by 23 on both sides, or negative 23, we end up with x equal to 69 over 23, and a negative divided by a negative is a positive, so we end up with 3. X equals 3. And then we just simply substitute that back into either equation to get y. I'm going to pick the first one, so we get y equals negative 5x plus 16, and I'm putting that x equals 3 into there, right? I'm substituting it in. Y equals negative 5 onto 3. Plus 16, that's negative 15. Negative 15 plus 16 is equal to 1. So our values, or our answers are there. we have our x value and our y value. Our x value, this is an arrow, our x value is equal to 3, and our y value is equal to 1. So we simply put that 3, 1 as our answer, box it. That's our solution. And that's where the lines cross, and that's solved by substitution.